Welcome to the final lecture on biodiversity. We'll be looking at what's happening in the world to biodiversity today. Biodiversity today is under attack. This chart shows several categories of organisms, birds, mammals, amphibians that we have assessed. We've looked at their populations and measured. How are they doing? Are they healthy? And you can see here in red percentages of those populations that are threatened or at risk for extinction. This has led many scientists to say that we're in the midst of a sixth mass extinction. There have been several times in Earth's history where things have happened that have caused a vast number of species to go extinct. You can see them here pointed out, 5 in the past, and scientists are wondering, are we in the midst of another? Extinction's a natural process. Species go extinct. Scientists think that maybe on average about 6 species every year would go extinct, but we're experiencing something that's about 1,000 times that. So how do we know where we're at with biodiversity? Well, there's a group called the IUCN, the International Union for the Conservation of Nature, and they keep a red list. The red list categorizes organisms based on how they're doing, and so there's some that we're really not concerned about. Maybe the North American raccoon or something. They're healthy, they're doing great. There's others that are extinct. They no longer exist. From moving up from there, extinct in the wild. They exist in zoos in captivity, but not out in the wild. And then we have this category of threatened. They're at risk if things keep going how they're going. They're at risk for going extinct. The IUCN every once in a while publishes a report that summarizes all the data they collect. You might want to pause here and take a look at these charts yourself. I'll point out a couple of the major things. First of all, amphibians are in trouble. They're not doing well, and it's actually been a little while that they've not back into the 80s and before they've been struggling. One group of organisms that's really at risk today, decreasing quickly, are our corals. Our coral reefs are in trouble worldwide. So after seeing those reports, you might ask yourself, does it matter? Humans as a species are doing better than ever. Over the last few centuries, we've seen continued increase in prosperity. So if you're forgetting some of the reasons that biodiversity is really important, go back, check out the video about the importance of biodiversity. But there's also something else I kind of want to try to ask you to reflect. The world around us is changing, and you might not even notice it because you were born into a world that's already changed. For instance, this is a passenger pigeon. You've never seen a passenger pigeon because they've been extinct. They've been extinct in North America for a long time. However, they used to be the most abundant bird in North America. There were over 1 billion of them. There's reports about them crowding out daylight as they flew overhead in flocks. They could fly at 60 miles an hour, and someone reported that a flock passed overhead for 3 hours over their head uninterrupted. Can you imagine how many passenger pigeons that was? This is a Chinook salmon. They're not extinct, but you'll never see a salmon like this anymore. This was referred to as a June hog, and so salmon would come up the Columbia River, and they were enormous. These are the kind of salmon that an orca would be really happy to be able to get a bite of. This is an old-growth forest. Much of the area around Seattle and Vashon in particular would have looked like this not that long ago, 100, 200 years ago. It doesn't anymore. So why are we losing biodiversity? Well, we can summarize some of the major threats to biodiversity, and here's an acronym for you, HiCOP. So maybe you can imagine the biodiversity police telling you why biodiversity is under threat. HiCOP stands for habitat loss, invasive species, climate change, overexploitation, and pollution. Let's take a look at habitat loss first. It actually comes in many forms. One of them is destruction. So simply destroying habitat, getting rid of it, putting something else in its place. Here is a picture of Seattle. You can see the city of Seattle is here. There's Elliott Bay. Here's downtown. And you can see this habitat's very changed. Look how much habitat is destroyed. It's been paved over. It's concrete here now instead of the lowland forest it would have been before. And then this is Vashon Island High School. You can see this big mound of dirt. This was from a year or two ago while the new track was being built. And so all this area, we're changing. We're actually destroying habitat in order to put a school there. Another issue with habitat loss is disruption. We change habitats, or habitats are being changed, and so Everything in an ecosystem is connected, and there are those keystone species that if we lose a keystone species, if we disrupt the ecosystem, like if this otter is hunted toward the point of extinction because its furs are valuable, well, that's going to have a really big impact on the sea urchin. Their population could explode. They'll eat the kelp forest. So many of the things that live in the kelp forest and use that area for habitat will disappear. Biodiversity will decrease greatly. One really interesting phenomenon is fragmentation, and that is when we break big habitats into smaller pieces. And so here's an aerial map of the western part of Washington state, and what I want to point out, I want to zoom in on this region and zoom into something that's fragmenting the habitat. This is actually I-90 weaving its way across the state and up through the Cascade Mountains, and it breaks the habitat up. Instead of being one continuous habitat that runs the whole length of the Cascade Mountains, there's now actually a barrier there. And you might think, well, that's such a little thing. What's the big deal? Well, it provides a serious barrier to a lot of species. Some species can't move across this road. There are several lanes of highway, cars moving incredibly fast, and so effectively we've taken one habitat and broken it up into two. Breaking up the habitat into smaller pieces has really big impacts for certain species in particular, like this mountain lion, or maybe for a mammal that needs to migrate, like elk that need to move from the highlands to the lowlands every day, and they now have a highway in their way. This diagram shows a patch of habitat before it's broken up, and it's a big piece of habitat. Actually, maybe it's big enough to support 2 cougars. However, when it gets broken up into smaller pieces, maybe none of these pieces are any longer big enough to support a cougar. And so even though we didn't lose that much habitat, we did lose some species and their biodiversity is going to decrease. It also changes the nature of this habitat. Look, there's a lot more edge here. There's a lot more edge of habitat. You can imagine roads, and you can see kind of the edge of the forest. And the edge of the forest is different than the interior of the forest. And so species that thrive in the interior, they're going to lose a lot of habitat compared to species that thrive on the edge. This is called the edge effect. The next major threat to biodiversity are invasive species. Invasive species are species that have been moved from one place on the planet to another by humans, and in their new environment they're doing really well. They may not have natural predators, they may outcompete the native species that are there, and that actually is the inherent issue. They outcompete native species and they drive native species to the point of extinction. This is the North American bullfrog, so native to North America but not native to the western states. And this bullfrog is big, it lays tons of eggs, it eats everything else. It eats all sorts of amphibians, all sorts of insects, and it grows so rapidly, and it drives down populations of other native things. Climate change threatens all species, but there are certain species that are more impacted than others. This is a polar bear, and it, along with all Arctic species, are at particular risk as their habitat is disappearing rapidly. This is a white lemuroid ringtail opossum, and this is a species one of the most endangered by climate change. And the issue for this species is that it lives up high in mountains in Australia, and as it warms, this possum could move up the mountain, but it's eventually going to run out of room. There's no more mountain for it to move upward to. Coral reefs are being really impacted by climate change. Corals are really impacted by the temperature of the water, and also a related phenomenon, ocean acidification. And so they've kind of got a double whammy associated with climate change. And many scientists predict that if things continue the way they are, we won't have any or very many coral reefs left by 2050. O is for overexploitation. This picture on the right is actually a pretty fun picture because that's my grandpa and that's my mom, and they've got a big Chinook salmon there. And you saw a picture of one of those June hogs earlier in this presentation, and that was also a Chinook salmon. And why aren't there any more big Chinook salmon? Well, we overharvested them. We fished too many. And so it's not a problem that they caught a fish, right? The problem is that over time, too many people fishing too many fish and then being sold commercially. And you can see that over here. Look at this catch. We've simply become really good at catching fish. And so we're fishing all the fish out of the oceans. Overexploitation affects many species, whether it's fish in the oceans or whether it's trees and forests that are being harvested for timber. or whether it's bison on the Great Plains that were hunted near extinction by white settlers, or maybe it's elephants in Africa that are being poached for their tusks. And P is for pollution. I've got an example of one type of pollution for you, and that's chemical pollution. In the 1950s, DDT, this chemical was developed, and it was kind of a wonder chemical. It did a really good job at killing insects, pest insects, and actually, it's used very effectively to stop mosquitoes. And so it seemed like it didn't have any impact on human health, and so it was used widely in the environment in the 50s and 60s. And unfortunately, it had some unintended consequences. One unintended consequence was on our bald eagles. All right, that's a little bit big, but bald eagles were impacted, and they weren't supposed to. DDT wasn't directly toxic to eagles, but here's what happened as DDT traveled up the food chain. There's a concept called biological magnification, and that is some pollutants get concentrated. You can see these little dots represent pollutants, and maybe there are 25 of them in here, and those 25 little molecules or whatever they are spread out in the algae. There's lots of algae, there's lots of producers. And as we move up the food chain, the primary consumers, there's less of them. But those pollutants there's still 25. They all got passed up. They've now just been concentrated in the bodies of fewer consumers. And as it moves up the food chain, the same thing. There's fewer at the next link in the food chain. Those get concentrated. And finally, we get to the very top of the food chain, and the top predators end up with really high concentrations of pollutants. And that's what happened to the bald eagles. And the DDT actually affected them in that it interfered with how their shells were made, and so these birds were producing eggs that had really thin shells, and they were breaking in the nests before their offspring could incubate long enough to hatch. Another really surprising pollution issue is actually pollution of nutrients. And so we fertilize farmlands with things like nitrogen and phosphorus, things that help plants grow really quickly. Well, when they run off from land by rain and water flowing into larger bodies of water, those nutrients fertilize the algae that's growing in those bodies of water. You might think that's great. Okay, if there's more algae, there can be more things to eat the algae and all the way up the food chain, and that might be true for a while. But eventually what happens is these large algae blooms, and they settle down to they die. The winter happens and the algae die. They fall to the bottom, and there they decay, and decomposers use up all the oxygen in the water, and it creates these large dead zones with no oxygen, so nothing can survive. Here's the Gulf of Mexico, and this chart shows oxygen levels, and actually this area becomes a big, huge dead zone. This is the Mississippi River, and the Mississippi River carries tons of nutrients out into the Gulf of Mexico because there's so much farmland here, and we use excess nitrogen fertilizer and phosphorus fertilizer, and that ends up in the Gulf of Mexico, creates a huge dead zone. This happens every summer. And we have some of the same issues here locally, and so this is the Hood Canal, and in the Hood Canal there's not actually that much farming that happens, but people live in homes along the water, and those homes often have septic systems, and excess nutrients from human waste ends up in the water, and we end up with the same issue. Plankton blooms, those plankton blooms die and use up all the oxygen. Whew, are you depressed yet? Sometimes we can't really do anything about the issue until we really understand what the issue is. And so it's important to understand all those threats to biodiversity, but I do want to take a moment now and look at what can we do about it? How can we reverse? If we think biodiversity is important, and by now you really should think biodiversity is important, what are we going to do to fix the problem? Well, I'll kind of address these in turn, and so I'll just give you some of the solutions. There are so many. We just need to make it a priority to implement them. And so habitat loss is a major threat to biodiversity. This shows the restoration of habitat. Up here in this before picture, you can see there's been a bulkhead built. Habitat's been destroyed here because this bulkhead changed how the water interacted with the beach. It stopped water from moving up. Here it kept land from eroding. It changed this interface. And so you can see this beach looks very different than afterwards. Once the bulkhead has been removed, it's been restored to a natural beach. This habitat provides so much more room for creatures. There are arthropods and all sorts of invertebrates that live in the seaweed that feeds the salmon and the other forage fish in the water. This is really healthy habitat. Just last year, for the first time ever, more bulkheads were removed in the Puget Sound than new bulkheads were built. That's amazing. Here's a way to mitigate habitat fragmentation. This is I-90, that highway that creates a really big barrier in the Cascade Mountains. And this is called a wildlife corridor. They built a bridge that's now connecting the two habitats. Up on top of the bridge, they're going to plant trees and shrubs and bushes. And so things that need to migrate across here, cougars or maybe elk, will actually be able to cross. They've taken the habitat, they've connected them back together. They've made two small habitats into one bigger. Invasives are incredibly difficult to control. The worldwide and in the United States, we spend an astronomical amount of money controlling invasives because they do actually a lot of harm to our economy. So the best way to deal with invasives is actually to prevent the spread of invasives. And so this chart is a reminder that if you're moving your boat from the ocean or from one lake to one river to another, to make sure to wash it really well, make sure there are no hitchhikers on the boats. Big transport ships actually bring water into their hull to help them sink down in the water and make them a little bit more stable. And before they're allowed to enter the Puget Sound, they have to actually dump all their ballast water. Climate change is something that we're facing as a planet, and so it's going to take planetary action. We need governments and economies all around the world working together to change climate change. And so this chart shows the countries that joined the Paris Climate Agreement, and you can see some patterns here. Climate change needs major action at the level of governments that control major economies, but there's also, of course, a lot of things that you can do to help fight climate change, and that includes in a lot of ways living a more simple lifestyle, or driving your car less, consuming less. So humans as a species are smart enough to decide how we interact with other species, and so we can actually pretty easily prevent overharvesting. We just need to harvest less, we need to eat less, we need to consume less, and we can do that. And so there are regulating agencies like the Washington Department of Fish and Wildlife that set limits to how much people can catch, how long they can catch during what season, and that prevents overharvesting. Actually, as a consumer, you can do a lot too, because worldwide, regulatory systems are not as good as they are in the US. In some places they're better, but in many places they're not as good. And so you can find stuff in the store that's not been caught sustainably. You can buy fish that's being overharvested. It's literally being hunted to extinction, and you can be part of that because you bought it at the grocery store. And so there's ways to avoid doing that. You can actually be part of the change here. And so the Monterey Bay Aquarium puts out the Seafood Watch. There's a few other organizations, and they tell you these fish are good. These ones are okay to eat. There's other ones, avoid them because otherwise you're contributing to their extinction. And finally, what can we do about pollution? Well, as an individual, your direct actions, not really that much. You can remember to do things like not flush your prescription drugs down the toilet, or any drugs for that matter, or you can use more you can use less harmful cleaning chemicals in your house. But those impacts will be really dwarfed by the amount of pollution industry can create. When industries manufacture products, there's always waste, there's always pollution. And what companies do with that pollution, whether they clean it up or whether they pump it right into a river, is going to be entirely dependent on what the government makes them do. It's cheaper, it costs less money to just dump raw sewage or chemical byproducts. But governments can make companies clean those things up, pay to clean them up. And so what do you need to do? Well, you need to elect officials that are going to regulate governments. You need to elect officials that are going to fully fund the Environmental Protection Agency that regulates industries. At least that's what we need to do if we want to protect biodiversity from pollution. And I will say that this has worked really well in our country. Actually, in the 70s and 60s, the air quality in our country was way worse. Water quality was way worse. But what did we do? We put regulation in place, the Clean Water Act, the Clean Air Act, and that cut down on these sources of pollution a lot. I want to leave you with a success story because as humanity, we really can change things. We got us to the place where we're at, but we also have the power to change it. And so this is a humpback whale. Humpback whales were hunted to the point of extinction. They were hunted until there were maybe only 10,000 left, which is not a lot considering that they can be found in every ocean in the world. And so what about today? Well, today we have about 80,000 humpback whales, and so they're making a really big recovery. They're still probably not at the historic level that they once were, but there's progress, and they're still growing. There's still more and more whales every year. And so we took action. We banned worldwide whaling as a global community. We've also, like in this country, put in place things like the Endangered Species Act, where we actually can't do anything that would disturb these whales while they're endangered. And so there's hope, and together we can make the future better.